and the advantages of all those investment appraisals. Generally, when you invest capital, you are investing in two types of investments. One is on annual operating inputs, such as purchase of fertilizer, purchase of seed, purchase of those things that you are going to use up within the growing season. The other type of investment is investment on capital assets, land, buildings, machinery, and so on. With respect to the operating inputs, the profit maximizing level can be deduced through the use of marginal principles, calculating the efficiency, using your production function, all sorts of things, all those economic principles, so that you can understand the resource use efficiency with respect to operating inputs. But when you are dealing with capital assets, you need a proper analysis of the capital assets in a different way from the approach used in analyzing investments in operating inputs. This is because when you are trying to analyze capital assets, you have to take into consideration the time value of money. So the first concept that you have to be familiar with is time value of money. When we say time is money, that means if you invest one Emalangeni today, for instance, it is believed that it can earn interest in the future dates, which means in the future you are going to have your principal plus the interest. And this is having an investment view of money. Another way to view it is to view it from consumption perspective. You know, the first perspective is investment, or we call it production perspective. But you want to look at it from consumption perspective. You can view that it is better to spend one Emalangeni on consumer goods, let's say on television, buying input, or something today than later, to increase the satisfaction. Because if you spend it today on the consumer good, definitely you derive more satisfaction than spending it on the same consumer good later in the future. From the investment point of view, time value of money can be discussed in terms of future values or present value. So when we talk of future value, for instance, is value of an investment at a specified date in the future. And the concept assumes that investment will earn interest, and most likely the interest may be reinvested. The procedure of computing future value is what is generally called compounding. I think you are all familiar with it. That is where the idea of compound interest comes in. Here is a typical example. Assume you have just invested 100 Emalangeni in a savings account, which earns 6% interest compounded annually. We would like to know what the future value of the sum will be, let's say after 3 years. The formula is what we have here. FV equals to P into I into 1. That one is not I, it's 1 plus I to power n, where our FV is the future value, the P is the present sum that we want to invest, and I is the interest rates, and our n is the number of years. Now, if you look at the example we have there, for instance, our P is 100, then our I is 6%. This cannot be 0.00, it should be 0.06. It's a mistake. Correct it. It's 0.06, not 0.006. Then the n is to the power of 3. So if you try to calculate that, then you get 119 Emalangeni.
So, sorry, Prof, what does the 1 mean?
1 plus I is the interest rate. You know, we are talking of in the future.
Oh, so that's not I, it's 1.
It's 1. That's why I'm saying it's 1. I told you it's 1. It's not I.
Okay. Thank you, Prof.
It's 1, yeah.
1 plus I.
Yeah, it's 1 plus I, not I.
Okay.
It's a mistake. Please try to correct it. So you do that, then you get 119.1 Emalangeni, which is the future value. So the future value of investing 100 Emalangeni in saving account compounded at 6% interest rate for 3 years. It's going to give you 119.1. So, and like I said, we will see how to do that also using R. And I hope you are all with your laptop with you, because I want you to know it.
Yes, Prof.
Okay.
Yes, Prof.
All right. Ilili, are you with your laptop?
Yes, Prof.
Okay, that is good. So, because that is the essence. So you will need Thinker. I think you all have Thinker package.
Yes.
Okay.
Yes.
That's good. So maybe you should open your laptop straight away so that we'll be on the same page. So try to open your laptop, then don't forget Library Thinker. So immediately you have done that, it's very, very simple to do. You start with the interest rate, that is R. In our case, it is 6%. Then you follow it by the number of years. In our case, it's 3 years. Then the present sum. The present sum in our situation now is 100. But since you are looking at, you want to calculate the future value, you have to put minus here. So minus 100. So if you do it correctly, then it's going to give you this. Try to check whether you are going to get the same answer. That's very good. So let me share my app also with you so that you can see how it is done. I hope you can see my R Studio.
Yes.
Okay, that's it. So try to follow what I have here.
3.
Yeah, this is just the question here. We have assumed you have just invested, blah blah blah. Then there you have the interest rates, the number of year, then the present sum. Then you use that to compute the future value. So if you do it correctly, highlight it here along. So if you do it, you get 119.1. So let me wait for you to finish it.
Yes, Prof. 119.1.
Yeah, that's great. Idili, are you there?
Yes, Prof. I'm trying to do it.
Okay, please. We are waiting for you.
I got it, Prof.
Oh, that's great. Zwani, can you join us? Have you joined us now? Yeah, I think. I don't know what's always wrong with Zwani. His audio is not working. He's supposed to have changed all these things. It's always like that every time. So Billy, when you finish, let's hear you. So that we'll be on the same page.
I got it, Prof.
Oh, that's great. Yeah.
Yes, the 1 point.
Okay.
The same answer as yours, yes.
Okay. That's fine. So I think then we can move forward. So now we have another example here which I want you to try. What is the future value of 1,000 deposited in a saving account at 5% interest for 10 years? Then recalculate the future values at 7%, 10%, 12%, 15%, and 18%. I hope you can see the question.
Yes, Prof.
Okay.
Yes, Prof.
Yeah, I want you to try.
Is it okay if we round off the answer to 2 decimal points?
Yeah. You can round it. Yeah, it's always good to round up to 2 decimal places. Yeah, most of the time we think of 2 decimal places in currency.
Prof, please put back the screen.
Okay, sorry. Yeah.
7. 7, 10, 12, 15, 18, 7, 10.
7, 10, 12, 15, 18.
So 15.
Then 18 is the last one.
I'm done.
Okay, let's wait for the other people, and then we now compare our results. Ilili,
Yes,
are you
Prof.
through? Are you done?
Not yet.
Okay.
I'm done, Prof.
You are done. Okay, that's good.
Yes.
Swami, are you there? Can't get in, so I think I work with the two of you. So what's your answer for the first one, which is 5%?
It's 1,276.28.
8, yeah, that's great. For 7%,
1,407.10.
Mine is different.
Man, is it 7?
for 7, what's your answer? You are wrong. Really?
I'm wrong. Wait, Prof.
Okay.
Yes. I got the 1.407.10.
No.
I have
Fiona, what's
1967.15.
yeah, the correct answer should be 1967.15. Do it again.
Oh.
I think you are using 7 years against 5% instead of 7%, 10 years. That's what you were.
It has to be 7%. Oh, yeah.
Oh, yeah. Look at the question very well. So,
Yeah,
Okay, Prof.
I changed the years instead of the percentages. I
yeah.
can see now.
Oh, okay, Prof. My first one is not 14, it's 1628.90.
For 5%?
Yes.
5%, 10 years, 1,000.
Yes.
The correct answer is 1628.90.
Yes, that's the one I
Yeah,
have.
0.90. Yeah, that's the correct answer.
Okay.
You have to be very sure so that you are not
10 years.
you are not
Okay.
using, yeah, it's 10 years. It's the percentage that is changing in the question. If you look at the question very well.
Okay, I think I have to redo everything.
Please.
Just a minute.
So, Philile, what you can do, so the first one, just copy and paste 5 times
Yeah,
below.
I'm trying to
And
do
change
that.
the interest rate
yeah.
only.
7. Yeah, I'm trying to do it. To do that.
Yeah.
0.10 at
Open,
10.
open.
Then
Yeah, you are
12.
trying to, I'm listening.
And then 15. And 18 minutes.
Yeah, I'm in elections. So.
If I have to get the one for, say, let's copy, is it 7 or 5, Jan?
On 5.
On 5.
On 5%, I have 1628.90.
Yeah,
Right.
for 10%.
Yes, I got point. Yeah, okay. Yeah, I also got that.
No, for 10%,
Then
I got
on
2593.
7%, it's 1.9.
1967.15.
All
Yeah,
right.
that's good.
Yes.
For 10%, what did you get?
2593.74.
Yeah, that's great. So
I also got the same.
for 12%, what did you get?
3105.85.
Same.
Good, yes, 3105.85. Then for 15%,
4045.56.
really, did you
Got
get
the
the same
same.
thing?
Yes, I got the same.
Okay. Yeah, that's good. Then for 18%,
5233.84.
did you get the same thing?
Yes, Prof. Same.
Yeah, that's good. Yeah. Now we're on the same page. That's great. So that is how to handle it. So let's move forward. Yeah. Now, suppose 1,000 emalangeni is deposited at the end of each year in a savings account, which pays 6% interest. No, it's now different because it's deposited at the end of each year. So which means we are going to have streams of payments. If you deposit 1,000 emalangeni at the end of year 1, and it's going to be 3 years, which means it's going to work for how many years? 2 years. You understand it now? The other one you deposit will work for 1 year, that's one. So the way to calculate it is a bit different because this is the case of annuity. A stream of payment over time is what is called annuity. So if it's annuity, the formula is different. The formula is E into 1 plus I raised to power n minus 1 over I. So it's annuity. This is different. This is not sum. This is like a stream of payment over time.
Sorry, Prof.
Yeah.
The one, we are subtracting it from n, or are we subtracting it from the answer
No,
that will come out from 1 minus n?
You are subtracting it from 1 plus I raised to power n, not from n.
Okay.
So yeah. So if you look at it here, you have 1,000 into 1 plus 0.06 to 3, then minus 1. Not 3 minus 1. Then over
Everything minus 1.
exactly. Then over I. Oh, I is 0.06. This is a mistake. It's not 0.9. Please correct it. Let me correct it. Okay, that is the correct thing now. 0.06. So if you have done it correctly, then it's going to give you 3,186.6. And if you want to use R, sorry, because it's moving us too fast. You want to use R to do it. It's not FV. The difference now is, since it's annuity, it's going to be FV point annuity is there. So let's try to use R to calculate that and be sure you get the same thing. FV dot annuity, then the 0.06. Then 3.
I got it, Prof.
Oh, great. Let's wait for Pidili. Pidili, did you get it? You are still working on it.
Yes, Prof.
Okay, please. But it's very simple and straightforward. If you have done it correctly, definitely you will get it.
Sure, I got it, but I'm not sure if it's correct.
The answer is 3183.6. What did you get?
Oh, okay.
I got 3183.6.
Yeah. What did you get? Really?
Prof, I'm not. Okay. PV.
You have to, not PV, you use FV dot annuity.
FV, yes.
This is future value.
Annuity.
Yeah, if you say FV point annuity, in fact, it's going to come up. Then you have the interest rate, which is 6%. The number of years is 3. Then the amount deposited.
I got it, Prof.
Oh, that's fine. That's great. So now I want you to work with this. Suppose 100,000 the Malangene is deposited at the end of each year in a saving account, which pays 5% interest. Calculate the future value of this investment at the end of 5 years. Recalculate it. Let's see. Yeah.
Okay, Prof. So once you say at the end of each year, then we know it's annuity.
Sure. Is at times it is. At times they may say at the end, or at times they may say at the beginning. You understand it now? Yeah. But it's a stream of
at the beginning, what does it mean?
It means it's deposited at the beginning of each year.
So which one would I use to calculate?
Yeah, it's the same procedure, but you will now add for her. Let me show you what you will do. You will say type equals to 1 if it's at the beginning, But the one that we are doing is type equals to 0.
Oh.
So if the payment occurred at the end of a period, is type equals to 0. But if the payment occurred at the beginning of each period, then type equals to 1. You do get it?
Not quite.
Okay. Let me come back to the.
Okay, Prof. Can we see the interest rates sort of for the exercise?
The interest rates, okay, wait.
Okay, never mind. We'll check it on our notes.
Please check it on your notes. I think.
10,000, 3.5%.
This is it. Here you have. You mean for the exercise?
No, it's fine, Prof. I found it for the exercise.
Yeah, for the exercise is 5% for a start. Then you will now recalculate at 2%, 3%, 8%, and 10%. So let's try to do that.
100,000.
Yeah.
100,000, 5% and 5 years. 5% and 5 years. And then 2, 3, 8, and 10. 2, 3, 8, 10.
I think I'm done.
Me too.
Okay. So let's check what you get.
Put the wrong amount.
Okay. Did you get? Let's check your answers. So for 5%, what did you get?
55253.10.
Did you get the same thing?
55256.31.
Yes.
Yeah. That's good. Then we now move to 2%. So for 2%, what did you get?
520404.
Mine is confused. For 2%, how much did you get, Pilile? I got 205,000.
I got 520404.
For 2%, let me I worked that one for 5%. Let me do that of 2%. The only thing that is changing is just the percentage. So for 2% is going to be 0.02. The correct thing is 520404.
Okay, I did what Pilile did. I changed the years, not the percent.
Okay.
It's so tricky.
You have to be very, very careful so that you don't make that mistake. So do that of 3%, 8%, and 10%, and let's see where we are.
2, 3, 8, 10.
Or for 3%?
3, 8.
No, for 3% is 530913.6. Check it again. For 3%, the correct answer is
For
530.
For 2%, what did you get, Prof? 520404.
Yes, 520404 is for 2%. But for 3% is 530913.6.
Yes. 586660.1 for 8.
Yeah. Look for 8. Okay, let me try. I've not done that of it. Let me do it and be sure we're on the same page. For 8%, the correct answer is 586660.
0.1.
0.1, yeah. Lily, where are you?
Yes, I got the same, Prof.
Oh, that's good. So I think then for 10%.
610510.
Okay, yeah. That's good. 610510. Yeah. In all of us got it. That's great. That's great. That's great. That's great. That's great. So I think then we can proceed. Yeah, so that is that about future value. So let us now come to present value. When we talk of present value, is the current value of a sum of money to be received in the future. So and the process of calculating present value is what is called discounting. So it is direct opposite of compounding. So when you are dealing with future value, you are compounding. But when you are dealing with present value, you are discounting. So for instance, now, find the present value of 1,000 to be received in 5 years using an interest rate of 8%. This is the formula because we are discounting in this case. So it's the reciprocal here. So here we have the P, which is the future value now, then multiplied by 1 divided by 1 plus I raised to power n. So that is what we have done here, which is, and we have 681 Emalangeni. If you want to do it manually. And if you want to use R to do it, it's PV. So it's PV, just like before, PV. The only difference is instead of using FV, now you are using PV. That's not the difference. So this is the procedure. So I want us to try it. Let's go back to the question. Find the present value of 1,000 to be received in 5 years using an interest rate of 8%. So let me show you, okay, this is how to do it so that you are doing the correct thing.
PV 108 5 years minus 1,000.
Of PD. Start with your R is the rates. In your own case now is 0.08. Number of years. So what did you get?
680.58.
Fine, that's the correct answer. Ilili, did you get
I got
it?
the same, Prof. Yes,
Yeah,
Prof.
that is good.
Okay, Prof, does this mean that at the end of the period, the investor is going to get 1,680.58 cents?
Yeah, if you look at the interpretation, I think I showed the interpretation. Maybe I should share. Okay. In the interpretation, we say it means a payment of 1,000 emalangeni to be received in 5 years as a present value of 681 emalangeni. Another way to interpret it is 681 emalangeni invested for 5 years at 8% compound interest worth a future value of 1,000 emalangeni. Or in a more practical way, an investor should not pay more than 681 emalangeni for an investment which will return 1,000 emalangeni in 5 years, if there are alternatives.
Oh, so this means I invest 681 and my value will be 1,000 on the day that.
Yes, in 5 years' time at 8%.
Okay.
Yeah. That is the implication. You know, all those things are very, very important. In fact, I'm looking for a master's student that will want to work on this so that, because one main problem of farmers is the lack sense of investment, sincerely. So you see, many of them, they don't keep accounts. And if they keep accounts, the way they spend it, no, is another thing. And that is why some of them are poor, actually. Not that they are not working, I know it's not that they are not earning, but what do they do with their earnings? So one can work on this kind of a work, looking at maybe the potential of small-scale farmers to improve their earnings. So I want to work with them, get what they are earning, try to get the interest rate and so on, because it's always a problem. Because bank always here, we can't give them money. It's because many of them don't keep records. And again, in terms of what the way they plan their expenditure is very, very disappointing. So now, let's try this exercise together. Find the present value of 10,000 to be received in 5 years using an interest rate. Now we use 5%, 7%, 8%, 12%, and 20%. So let's try this. So let's work with this together.
$10,000.
10,000 in 5 years, 5%, 7%, 8%, 12%, and 20%. Take note, you are just changing the interest rate here so that you are not confusing. You are not confusing.
Are we changing the interest rate?
Yeah, you are changing the interest rates. And,
okay.
and don't forget you are working with 10,000, not 1,000.
Yes.
Those are the mistakes I feel you can make. But apart from that, I don't think there's any.
I'm done, Prof.
Okay, for 5%, what did you get?
7835.26.
Yeah, that's good. Pidili.
I'm still working on it, Prof.
Okay. Let's wait for you.
I'm done, Prof.
Okay, let's hear your results. Number for 5%, what did you get?
For 5%, I got 7835.26.
So that's great. For 7%, what did you get?
7129.86.
Yeah, 7129.86. The same thing, Pilili?
Yes, Prof.
Yeah, that's good. Then for 8%, what did you get?
6805.83.
Beautiful. 12%.
5674.27.
Yeah, great. Then 20%.
4018.78.
A clap for you. That's great. You all got it.
Same.
Yeah, that's great. That's great. So let's move forward. So like we have in the case of future value, also you can have streams of income in the case of present value. So suppose an annuity of 1,000 Ebalangeni will be received at the end of each year for 3 years, and the interest rate is 8%. Calculate the present value of the income stream. So for that, we use PV annuity. So the formula is 1 minus 1 plus interest rate raised to the power minus n over I. So this is what we're trying to work out here and go to 577. And for using R to do that, we use PV.annuity in that case. So try to, let's solve this. Suppose an annuity of 1,000 Ebalangeni will be received at the end of each year for 3 years, and the interest rate is 8%. So let's calculate the present value of the income stream. So the only difference between what we are trying to do now and what we've done is annuity. try to do that and let's see whether you'll be able to get the same answer. Progress?
Got it, Prof.
Yeah, fine.
I have it too.
Yeah, that's great. So that's EV annuity 0.08, 3. Then you have minus 1,000. Straightforward. Good. So now let's try this exercise. Suppose an annuity of 10,000. Please listen. No, you have two exercises here. Suppose an annuity of 10,000 Emalangeni will be received at the end of each year for 3 years, and the interest rate is 5%. Calculate the present value of the income stream. Then recalculate the present value if the annuity is received at the end of 5, 7, 8, and 10 years. Then recalculate the present value, the interest rate is 3%, 4%, and 10%.
Are we doing it now, Prof?
We are doing it now. Yeah.
Okay.
Yeah, I want you to, the more you do it, then the more you get familiar with it, so that you are not using year for, remember, the first one here, you are changing the year, not the percentage. And in the second one, you are changing the
percentage.
Yeah, not the year. So take note.
Okay. 5, 7, 8, 10. 5, 7, 8, 10. $10,000, 5%, 3 years. Okay. In the second part, Control V. 3, 5, 10. 3, 5, 10. 3, 4, 10. Okay. I think I'm done.
Okay, let's wait for Pilili. Pilili, are you done?
Not yet, Prof.
You are through?
No, not yet, Prof.
Okay. Let's wait for you so that we look at the answers together.
I'm done, Prof.
You are done. Okay,
Yes.
that's okay. So now let's look at for 3 years. What did you get?
Sorry, Prof.
Wait, Prof.
3 years. We know the first one is 3 years.
2577 point.
27232.48.
Wait, Prof. I didn't change the 1,000. It was.
Oh,
Yeah.
I told you it's 10,000.
27232.48.
Yeah, that's great. Yeah, that's then for 5 years.
For 5, 43294.77.
Yeah, fine. 7 years.
PD, that's your one.
No, that's what I'm telling you. You have. I know it could lead to some confusion.
57863.73.
Yeah, that's good. Then 8 years.
64632.13.
Yeah, then for 10 years.
77217.35.
Yeah. Okay. Then now for 3%.
28286.11.
Really? You get the same thing.
Prof, I don't know. I don't know where I made some. Okay, where are we now?
1,000.
Yeah, okay, wait, because look, some of the things for 3%.
3%, 3 years.
Yeah,
3%.
3 years.
For 3%, 3 years, I
3
got.
years.
Okay, for 3%, 3 years, I got 286.11.
Yeah, that's good.
I got the same.
Yeah. Then 3 years, 4%.
27750.91.
Good. Did you get the same thing?
Yes, Prof.
Okay. Then now for 10% is the last one.
24868.52.
I got the same.
Good. Yeah, which means believing you have to work with those changes in years. You know, you have 3 years, 5 years, 7 years, 8 years, 10 years. It's
Yes,
all
Prof.
at 5%. Before we now come to 3 years, then change in the interest rates.
Please say that again, Prof.
you have to first calculate with 3 years, 5 years, 7 years, 8 years, 10 years. That's changing those years at 5%. Then you maintain 3 years, but you now change the interest. Initially, you work with 5%, then you now work with 3%, 4%, and 10%. That's the question now. I think you got everything, Fiona, but I think I don't know where to do this.
I think I've amended, Prof.
Okay.
Yes.
No, it's just a matter of checking where you miss it. So that is just the exercise. Then now we are moving to investment appraisal. Investment appraisal. And I want us to pay attention because for this one, it's going to end up in an assignment. So yeah, this one will end up in an assignment for sure. So investment appraisal is the process of determining the profitability of an investment. You know, and that is what I'm saying. You know, it is not all the time you are running regressions here and there. You can actually look at investments, the profitability of an investment, using investment appraisals also. Even in projects, all these things are allowed. So, and it's very, very useful, particularly when you are comparing profitability of 2 or more than 2 investments. And what do I need to compute for my investment appraisal? Number one, I need my cash flow. And don't forget, we have done cash flow budgeting, so we should be familiar with the process of computing cash flow. Then you need the cost of the investment, that is the initial cost. Then you need the salvage value of the investment. Then you need the opportunity cost of capital, which could be interest rate on savings, or the current interest rate on borrowed money, or the minimum rate of return desired by the investor. So this, let's look at a typical example. Here we have 2 types of investments, investment A and investment B. This is spelling mistake here. This should be investment A and investment B. For investment A, we have the cash flow as 3,000 every year. But for investment B, we have 1,000, 2,000, 3,000, 4,000, and 6,000, making the total investments for A to be 15,000 and B for 16,000. So then you can calculate the average cash flow. Then if you remove your depreciation from the average cash flow, then you get your net revenue. So now let's say you have these 2 types of investments and you want to make it short. You want to choose one of them, then definitely you will need some appraisal techniques. So there are 4 different methods of analyzing and comparing investment that we want to look at. One is payback period. Then the other one is simple rate of return. Then we have the net present value, then internal rate of return. So let's look at them one by one. When the cash flow is the same every year, like in the first investment, it's very simple to calculate the payback period. So the payback period is the amount of investment, that is I. I there means amount of investment divided by E, where E is our expected annual net cash flow. The expected annual net cash flow is the average return that we have calculated. So in our example, it's going to be 10,000, which is the amount of investment, then divided by 3,000. So it's going to be 331 over 3, which is 3.333 something. So that is payback period. But you know, in the second one, that is in investment B, the cash flow is not the same every year. It's 1,000, 2,000, 3,000, 4,000, and 6,000. In case when you have that one, then you have to have what is called cumulative sum. That is, you have to sum together all those cash flow year after year. And you have to locate the year when the total is equal to the amount of investment. So that the year when the total is equal to the amount of investment will not be the payback period. So, and this is very, very useful to identify investment with most immediate cash returns. But the problem is that the time value of money is not taken into consideration when you are using payback period method. And to calculate it using R, it's very, very simple. It's just two steps. You have to use two steps. Step one, you calculate the cumulative sum of the cash flows. Then the second one, you identify the payback period. It's very, very straightforward to do. So for instance, now, in the first one, if you want to use R, we have our ECF, which is expected cash flow. Our expected cash flow is actually equals to 2,000 multiplied by 5. You know, that is 5 years divided by the number of years, which is 5. And that gives us 3,000. Then our amount of investment is 10,000. So you now say 10,000 divided by 3,000, which gives us the payback period for the first investment to be 3.3. I hope you understand how to use R now to solve it, particularly when the cash flow is the same for all the years.
Prof, is ECS still calculated under FinCal?
Yeah, you see.
Or the different package?
ECF is not, ECF is a name. This is expected cash flow.
Okay.
I give it the name. I say my expected cash flow, which is my average return. You know, I calculated it on the table before. But you know, it's possible you are not giving. This is what we have here. You know, every year here you have 3,000, 3,000, 3,000, 3,000, 3,000. So this is the ECF, which is expected cash flow. That is this 15,000 divided by 5. That is 3,000 multiplied by 5 is 15,000 divided by 5. That's how I obtain this 3,000. Is that clear? Is that clear? Hello? Hello?
Yes, Prof.
Prof, I am lost.
You are lost.
I don't know what happened to my internet. Yes.
No, it's not yours. It was Prof's.
It was Prof's. Oh, okay.
Not, I think the problem is for me. Yeah.
Oh, okay.
So let's come back. I think all of us can. Okay, Zwani, you are welcome. I can see his face now. So we have expected cash flow. The guy is making this 3,000 every year. So for 5 years, then you divide by the 5 years, you get 3,000. So then the amount of investment in the question was actually 10,000. So you divide by the net cash flow, expected net cash flow, which is 3,000. You get 3. So which means the payback period is 1/3 years for that one. Take notes. That's very important.
Okay, please can we type that last part?
You mean this 10,000?
Yes.
No, it's already in the question. Let's go back to the question. This is the question I want us. Sorry. I want us to look at the question. This is the cash flow. 3,000, 3,000, 3,000, 3,000, 3,000. But, okay, I think, oh, maybe I did not include the question. The question actually says that the cash flow for two investments, that is 10,000, this is 8 here. Can you see this?
Yes.
Yeah, this is showing the cash flow for
Yes.
two investments, and the investment is 10,000. But these are the different cash flow for different years. But it differs. If you look at the cash flow for investment A, is different from cash flow for investment B. So for investment A, you want to calculate the payback period. It's very straightforward because the cash flow is the same over the years. So we just divide, this is the 10,000 here. 10,000 divided by the average of this, which is 3,000. It's going to give us that is it. It's going to give us the payback period. So for B, for first one, it's always very simple to calculate. But for B, the first thing you have to do is 2 stages. Please take notes. Since you already have this note, you can just try it, copy, run, and so on. So what you need to do is to calculate the cumulative sum. The cumulative sum in this case is, you say cumulative, no, cum sum. This is what I call CCF, cumulative cash flow. So cum sum, that is the function in R. Then C, since we are dealing with so many cash flow, C 1,000, 2,000, and so on. So this one will give us the cumulative cash flow. Yeah. Then now to know the second thing is now to know the payback period. You will now use minimum which CCF, that is where our CCF is greater than 10,000, then you say -1. That is how to solve it. That's going to give us 4. So which means the payback period for the second one will give us 4 years. Take note of it. That's very, very important. Or you want to try it yourself, because you can just copy, paste, or you try it. That's very, very important. I want you to try it. Since you are going to work with it later, but yeah, try to work with it. Did you get it?
I did not get it.
No, you should. At least you should get the first one for sure.
Okay, I see what I did wrong.
Okay.
I think I got it.
Oh, that's great. Really? Progress?
Yes, Prof.
Did you get it?
Not yet.
Okay, try it. Wani, I hope you are following us. Okay.
I got it, Prof.
Oh, that's great. You got the first one or the second one or both?
The second one. I didn't know we're doing even the other one.
Okay. For the other, yeah, I think you got the one for 15,000 divided by 5.
Yes.
Okay, which is the first one. For the second one, copy and paste it and read it and understand it.
Okay.
Did you get it?
Not yet, Prof. Okay, let me just.
Fiona, did you get the second one?
Yes, Prof.
Okay, yeah, she's 4. Yeah. Very straightforward.
Hmm?
Progress, Pidili.
I don't know what I did wrong, but I'm trying to copy and paste, Prof, and running
No,
it.
I think maybe you copy that greater than.
Oh, I shouldn't.
No. Just remove that greater. Everything will work.
Oh,
Yeah.
because it's sending an error code.
Yeah, that's why it's sending.
I got it, Prof. I got the form.
That's good. So let's move forward. Now, to calculate the simple rate of return, it's very, very straightforward too. So the simple rate of return is the average annual net revenue, which is your expected, that is when you subtract the depreciation from your expected net cash flow, then you divide it by the cost of the investment. So for project A, if you look at it, it's 1,000. So you have 1,000 over 10,000 multiplied by 100, which is 10%. Therefore, project B is 1,200 divided by 10,000 multiplied by 100, which is 12%. So now you look at it that way. So simple rate of return, very straightforward. There is no problem about that. So try to do that also in your R. It's straightforward, since you know it. So that you have everything in your R. So call that one SRR. Then we have SRR1. So that is SRR equals 1,000 divided by 10,000. Multiply by 100. Then for SRR2, have you done it?
We were writing it, Prof, right?
Yeah, just go to your app. You say SRR1 is equal to 1,000 over 10,000 multiplied by 100, and you get 10. Just like your normal, just like writing it on the blackboard. Yeah. Then project B will be 1,200 over 10,000 multiplied by 100. That's going to give you 12%. Waiting for you. Progress. Fiona, have you done it?
I'm trying to do it, Prof.
No, it's very straightforward now. We get 10 for the first one, then 12 for the second one.
I did it manually.
You do what?
Prof.
Yeah.
Is that wrong? I did it manually, not in R.
No, you don't have. You just type it. Just type 1,000 over 10,000 multiplied by 100. That's all.
Okay.
It's straightforward now. So what are you trying to do?
You, Prof.
It's straightforward. Let me give you a few seconds to do that again. But it's straightforward. There's no problem about it at all. There shouldn't be any problem.
Divided by 10,000.
So, okay. Why is it taking us too long?
I have it, Prof.
Yeah, that's great. So you know the disadvantage of simple rate of return and payback period is that the timing and size of annual earnings are not taken into consideration. So let us now move forward. Another method is net present value. And the advantage of this over payback period and simple rate of return is that time value of money is accounted for in this method. And it's very straightforward. It's the sum of the present value of each year's net cash flow less the initial cost. So it's just calculating the PV for each year, then sum over, then you subtract the cost of investment from it. For instance, for project A, the NPV will be, for the first year is 3,000 over 1 plus this 8%, raised to power the first year, 3,000 over this over the second year, and so on and so forth. Then you now subtract the cost of investment, which is 10,000 from it. You do it properly, manually, then you get 1979. And for project B, you get 2,048, that is manually. So, but to use how to do it is very, very, very simple and straightforward. What you just need is the interest rates, then the cash flows. But take note of one thing. Your first cash flow must be negative, which is the initial outlay. Your initial one must be the cost of the investment, and it must be negative. So for instance now, for project A, it's going to be NPV, our R is 8%, then our cash flow will now be equal to C. The first one must be minus 10,000. Then these are the different cash flow, 3,000, 3,000, 3,000, 3,000, 3,000. It's very straightforward. If you have done it correctly, then you will get 978.13. And the same applies to project B. The interest rate is 0.808. Then the cash flow equals The first one, don't forget, is the initial capital outlay. Then now you have the streams of the flows. Then 1,000, 2,000, 3,000, 4,000, 6,000. It's going to do this. So it's very, very simple to do using our software. So I want you to do that. It's very straightforward. Using NPV.
Minus 10, 10,000.
3,000.
3,000. Okay, and then let's remove this. And then NPV. Equal 0.08. Number cumulative frequency equal C minus 10,000 1,000, 2,000, 3,000, 4,000, 6,000. I have it.
Yeah, that's great. Let's wait for Bidili and Swani. If Swani is trying, I know Swani, we have to do it after the class, maybe because I think he lost some of the time.
I got it, Prof.
Oh, fine.
But I cheated because I cheated, Prof. I did copy and paste.
Oh, if you do copy and
But,
paste, you will see include project A. So it's not going to work. So, yeah, you don't have, if you want to copy and paste, then you will not include project A dot. Then it's going to work for you. So that is it. Yeah. So let's go back to. So the last one we want to look at is internal rate of return. You know, the difference between NPV and RR is that you just equate your NPV to 0. That's all. So it is actual rate of returns on an investment. For instance, now we'll be using different interest rates, 8%, 3%, 4%, but we don't know actual rate of returns on the investment. The actual rate of return on an investment is what is called internal rate of return. Another word for it is marginal efficiency of capital, or that is what is normally called the yield on an investment. It is the discount rate which makes your net present value equals to 0. So the equation is the same as the NPV, just summing over the present value for different years and subtracting what is it, the cost of investment from it. So, but the rate at which your NPV is equal to 0 is what is called the internal rate of return. So in the absence of a computer, it's not easy it normally depends on trial and error. So you will try various percentages. So you look at interest rates where your NPV is equal to positive, then you will get another interest rate where your NPV is equal to negative. Then you will now use this formula. IRR is equal to R1 plus NPV1 into this in order to calculate your IRR. But since you are going to be making use of computer, to me it's very simple. Just use your R to do it. I'm not expecting you to do it manually anyway. But it's good to know how to do it manually. That's why I've given you all those equations. So it's so simple, just like before. Instead of NPV, you use IRR. That's all. Then you have your cash flow, just like before. Nothing has changed. In this case now, since you want to calculate the interest rates, there is no interest rate you are using. It's going to calculate the interest rate for you. So here we have for the first project, which is project A. Let me change this to project A. So for project A, we have the IRRs. Just bring in the cash flows, but make sure that the initial capital outlay is a negative form, that is minus 10,000. Then you repeat that for the second project, which is project B. Very straightforward. So try to do that. And, I want you to do it so that we have everything, so that we are on the same page. If you do the first one, you will get 15.2%. And if you do the second one correctly, you will get 12%.
Yes, Prof.
Yeah, that's great. Pidili, progress?
I got the first one, Prof. I'm still.
Yeah. Please work on the second one too. Yeah. Work on the second one.
Prof.
Yeah, you got.
I'm sorry, I need to leave.
Okay.
I got it.
Yeah. Now that you want to leave, because the only thing that remains, look at the assignments before you go.
Okay, Prof.
Yeah, and the deadline is Tuesday, 22.
No problem, Prof. Speaking about that, says Corner Zwane, he says 24 at 11 is okay. Thursday, 24 at 11 for the online test.
Okay, 24. Okay.
At 11 a.m.
11 a.m. on 24th. Okay. That's all right. Yeah. Yeah, I will send the link to you to remind you. That's okay.
Oh, it's Wednesday.
Maybe you can confirm if
yes,
it's
24
Wednesday
is
or
Wednesday.
Thursday.
Yes, it's Wednesday.
Yeah.
Okay.
Okay.
Thank you, Prof.
All right. You're welcome. Yeah.
Okay. Bye.
All right. Bye. So, Pidili.
Yes, Prof.
Did you get it?
Yes, I got it, Prof.
Yeah, that's okay. So now This is your assignment. You already have it in the slide I sent to you. So you have a maize processing company in Bonini. Can select one of 4 mutually exclusive projects. The estimated cash flows are, which means you have 4 different projects, different cash flows. Then given the following cost of capital, see 0%, 3%, and so on and so on. Compute the payback period, simple rate of return, net present value, and the internal rate of return. Yeah, and based on the result, provide expert advice on the financials. I expect this to come in by 22, hopefully. Any question, Pilili? I think you are the only one left behind now. Yeah, the other 2 have left. Yeah.
No question, Prof. If there is any question, I think we'll ask on WhatsApp.
Okay, that's all right. So I wish you all the best. That is all for today. Let me stop sharing. So, okay, since we don't have any question, I'm ending the class. So please, bye-bye.
Bye, Prof.
All
Thank
right.
you.
You're welcome.